Lesson 19.5, Task 1. So in the textbook, Task 1 was missing, so I'm just going to use this straight from your textbook to make sure that we don't skip this information. All right, so use second differences to identify a quadratic data. Given a set of data pairs x and y, that's just an ordered pair, with evenly spaced x values, you can know that the data can be modeled by a linear function if the first difference in the y values are constant. If the first difference are not constant, but the second differences are and the y values are constant and non-zero, then the data can be modeled as a quadratic function. All right, so this tells you, this helps tell you whether it's linear or quadratic. Over here is some vocabulary terms that you need to know. First, differences are differences between the y values. So you see here, we find the first difference by doing 4 minus 1, 9 minus 4, 16 minus 9, etc. So this first difference comes from this column here by just subtracting. The second difference, the differences between the first differences are called the second differences. So the second differences, if you do 5 minus 3, you get 2, and then whatever this is minus 5, you get this answer, so on and so forth. So this column is found by taking the difference of the first differences. All right, so it says copy and complete the table. All right, so to find the first difference, you can see all they're doing is taking the two y values from the previous term, so 9 minus 4 equals 5. So the next one would be 16 minus 9, and 16 minus 9 is 7. And then we would do 25 minus 16, and that equals 9. All right, and then we find the second difference by doing the same thing except with the previous column. So you can see 5 minus 3 equals 2. So we're going to do 7 minus 5. 7 minus 5 equals 2. And 9 minus 7 equals 2 as well. All right, so you can see that these end up being the same. So that's going to tell us because this occurred during the second difference that this represents a quadratic model, okay? So these are your x's, these are your y's, or your f of x. F of x, again, is just function notation. These are your ordered pairs. And because these are the same during your second difference, that tells us that it is a quadratic function, okay? So just kind of a reminder up here. You can know that the data can be modeled by a linear function if the first difference are constant, meaning the same, and if the first differences are not constant, but the second differences are constant, then it's modeled by a quadratic function. So that's how I knew that this was a quadratic function. All right, so let's answer the questions associated with this. My numbers disappeared here, so let's put 7, 9, 2, and 2. All right, so it says, are the x values evenly spaced? All right, so we go from 1, 2, 3, 4, 5. So we can say, yes, these are evenly spaced by a value of 1. Okay? All right, C part, are the first differences constant? All right, here's my first differences, 3, 5, 7, 9. All right, so are those constant? So the answer is no. So that means the data is not linear, okay? All right, so let's write this down here. So let's write yes for this one. And if we explain, these are a difference of 1, so a difference. All right, are the first differences constant? So no. So not linear. All right, are the second differences constant? And what does this mean? So yes, the second differences were constant. So I got 2, 2, and 2, so that means these are quadratic. The data so the data represents a quadratic model. All right, so it says create a table to find the second difference for the data shown in the graph below. All right, so now we're going to look at a graph instead of the table. So we looked at the table first for one function. Now we're going to look at a different function, but we're going to start with a table, or sorry, start with a graph and create a table. So if we want to create a table, the first thing we need to do is just create our x and y values. All right, so if we create our x and y values, we're going to have x and y. And then after that, we would want to have the first difference. And then we would want to have the second difference. So just like above, but now we're going to create our own table. All right, so we're going to start with the ordered pairs. So we have 0, 0. And we have 1, -3. And we have 2, -12. 3, -27. And 4, -48. All right, and we know we can create this table because the x's are 1 apart each. So these are evenly spaced. All right, so now let's find the first difference. The first difference here, we're not going to have one, but we're going to go -3 minus 0 would be -3. -12 minus -3 makes that +3, so that would be -9. -27 minus -12 makes that +12, so -27 plus 12 is -15. And -48 minus a -27, so -48 plus 27 is -21. So again, these are not the same, so it's not linear. So we're going to move on to the second difference. All right, so we're not going to have one here. We don't have two numbers there. So we're going to do -9 minus -3. -9 plus 3 is -6. -15 minus -9, so -15 plus 9 is -6. And -21 minus a -15, or -21 plus 15 is -6. So again, you can see these are all constant. And so it says, what is true about the second difference from part E? What is true about the data? So the second difference are all the same, so that tells us that this is a quadratic model. Now if you look, you can see that curve starting there. If you have the reflection points over here, that should make sense that that is a quadratic model. So this shows you how to determine whether a graph is linear or quadratic using a table of values and finding the first and the second difference. All right, that's all for task 1. If you have any questions, let me know.